After this I will discuss gain calculation in OpAmp circuits. Then the third topic I will discuss that is transfer characteristics in OpAmp circuits. If time allows, then I will go to this also. Okay, so keeping these three things in the mind, let us start. First one is equivalent circuit. By equivalent circuit, what do we mean? Equivalent circuit means making a circuit using the basic elements which represent the same circuit that we are going to make equivalent. Like the equivalent circuit of BJT is like this. If you have already studied analog circuit, so the BJT is like this, HFEIB, and here as resistance HOE using H parameters. This is the equivalent circuit of BJT, bipolar junction transistor. For BJT, there here is HIE like this. There is something here also. What do you see? HRE, and this SFEIB, and this is HOE. This kind of H parameter model is for BJT. If you have field effect transistor, so if you have the FET equivalent model, I am just revising this so that you will be able to recall your understanding about the equivalent models of BJT, and this is VGS. So this is like this. This is FET equivalent model. GM into VGS comes here, and drain resistance RD comes here. This is FET equivalent model. And these models are prepared based on the equation of output voltage. The output voltage model, this output voltage is here, and here output voltage is here. So based on this equation of output voltage with respect to input current, these models are prepared. From this model, what we can say, what a conclusion can be drawn, that BJT is the voltage source dependent on the input current. So current controlled voltage source. This is a in fact you can say this is current controlled voltage source, or if you I can say, if I take current, I can take current also from here. So this is also a current source. So voltage source and current source coming in the output is controlled by current. Here you can say the output voltage is voltage controlled. Current source, basically it is current source because the current is coming because of voltage, and this current we are converting to voltage. So this is becomes a voltage source, but basically this is a current source. This is also basically current source, but because we are passing it through a resistance, this is becoming a voltage source. This is also a voltage controlled current source, and because we are passing through a resistance, this is becoming a voltage source. Important thing is this this is a voltage control, because input, this is controlled by input voltage, and this is current controlled because it is controlled by current. What about the operational amplifier in equivalent circuit? In OpAmp circuit, output voltage V0 is equal to AD into VI. You can say VI or V1 minus V2. Someone mistake. In this case, the equivalent circuit will be equal. Can be drawn as, here is a voltage, and here is a voltage source. This is a voltage source. In fact, this is because this is voltage. This is input voltage. So AD into VI. This is a voltage dependent voltage source. This is a voltage dependent voltage source. So what can be said about the OpAmp? This is voltage controlled voltage source. Because in output only voltage is there, so this is voltage controlled VCVS, voltage controlled voltage source. This is the equivalent circuit of operational amplifier, where there is voltage in the output. This is called voltage controlled voltage source. Okay, next thing that I told that I will discuss that how to calculate gain. So till the time we are calculating, what is the, I was giving the questions like that, what is output voltage, what is V0, this type of questions were there. But now if the question is changed to what is gain, what is gain AD, or what is gain of the circuit, then what can be done, how can this gain be calculated? Suppose I give this problem, very simple problem, minus plus like this. Here is 2k, here is 1k, here is 1.5k, and here is this is circuit. Input is Vi, like this. Determine gain of the circuit. What will be the gain in this circuit? Gain in the circuit will be equal to okay, let me change question. What is the output voltage? This is a just do calculations, small calculations, you will get answer. Minus of I want answer, then I will proceed further. I am waiting that someone should give answer to this problem. What is the equation of V0? That is equal to, I hope that this should come like this, into Vi. Yes, very good, Soumya. This is V0 equal to 0.75, yeah, V0 equal to minus 0.75 Vi, like this. So if I transfer this Vi to here, then this will become V0 upon Vi is equal to minus 0.75. Because gain cannot be negative, so this AD, this gain is calculated as V0 upon Vi absolute value, gain is equal to 0.75. This is how we can calculate the gain. Process is same. I think you might have applied the same steps. What were the steps to calculate, to solve any problem? First step is apply virtual ground concept. And second step, step 2 is apply KCL at node, and just in these two steps you will get the output. Definitely output will come. So here it is 0.75. This is the idea how the gain of any circuit can be calculated. So in this way you can calculate gain of any circuit, which has been discussed previously in this class. I will take one more example to verify that you have understood this calculation of gain. I am taking one problem from the previous lectures. This problem, the circuit goes like this. This is the circuit is R1 here and R1 here. This resistance is of 2 kilo ohm. This is resistance of 1 kilo ohm. Here is V1, here is V2. This is again resistance of 1 kilo ohm, and here is resistance of 2 kilo ohm in the feedback. These two are connected to an operational amplifier like this. Determine gain. AD. This resistance is of 1 kilo ohm. This resistance is of 2 kilo ohm. This resistance is of 1 kilo ohm, and this resistance is of 2 kilo ohm. What we need to find out? We need to find out the gain of this circuit. Good. I got first answer from Omji Gupta. The gain is 2. Anjali, great. This gain is coming 2. Yes. So the gain here will be 2 if you solve this question, and the relation between output voltage. If you solve this problem using the same process that we do, then we will get the relation between output and input. Output voltage, if you try to calculate in this circuit, you will get 2 times of this will be V1 minus V2. and the output voltage upon the difference of input voltage will be equal to 2. Therefore, the gain is 2. The answer of this problem is 2. The gain will be 2. Gain is unitless quantity, so we don't have to write here 2 volt. कोई क्या करेगा, बहुत होशियार होगा तो वो बोलेगा कि नहीं हम यूनिट के अगर आंसर नहीं लिखते. नहीं, दिस इज रॉन्ग. You don't have to write any unit in this. Okay, so I hope you have understood the two topics that I told. The first topic was the equivalent circuit of operational amplifier. Second topic was determination of gain in the circuits of operational amplifier. Third topic of today's class is characteristics. Transfer characteristics. Characteristics of OpAmp already has been discussed. What is transfer characteristics? This is important thing. Actually, transfer characteristics is the relation between output quantity and input quantity. Suppose we have any black box like this, and I am applying X as input, and out of this black box Y is coming as output, and suppose this is performing some function f, then the relation, the characteristics between of the output with respect to input is called transfer characteristics. Characteristics of the output with respect to input is called transfer characteristics. Here there was some system or circuit. This is in this circuit I have applied input as X. After application of this input, output is coming Y. As input is changing its value, the output is also changing its value like this. Then this characteristics of the system is called transfer characteristics. Very simple thing. Now let us think about the operational amplifier circuit. Inverting amplifier. Inverting amplifier. If I take inverting amplifier for plotting transfer characteristics, then I have to consider its circuit. I am applying here a voltage source of sinusoid which is varying in voltage, and output voltage is coming here. This resistance is of 2 kilo ohm and this resistance is of 1 kilo ohm. I can say this is R1, this is RF. Any value that can be taken, and because I am taking a general circuit, so I will not take the values. I am taking a general circuit for which transfer characteristics has to be drawn. What will happen when input is 0? When input is 0, then output is, when Vi equal to 0, then V0 is also equal to 0. This is very simple, because this is a amplifier circuit. So whatever input we apply, that input will come into the output. So because I have applied 0 input here, when 0 input is here, then 0 output will come. That is obvious thing. But if I increase the value of input, suppose I take it case 2, when Vi is equal to, suppose there is 1 millivolt, मतलब little plus, then what will come? V naught will be equal to, if let me take it, okay, let us take it 2k and 1k. So output voltage V naught will be equal to 2 millivolt. Okay, and that means V naught is equal to Vi, 2 times Vi. That is what means linear relationship. It will increase linearly. Okay, so case 3, when Vi is equal to, suppose 100 millivolt, then V naught will be equal to 200 millivolt. Simple. Okay, no problem. But case 4, when मैं शायद गलत बता रहा हूँ, आपको ये माइनस होगा, ये भी माइनस होगा. क्यों होगा माइनस? क्योंकि ये इन्वर्टिंग एम्पलीफायर है. यस, आपको बताना है बीच में, चैट में लिख सकते हो अगर कुछ मिस्टेक हो रहा है तो. कुछ अगर ऐसा, ये आपको ध्यान देना है कि यहाँ पर जो है -2 मिलीवोल्ट आउटपुट होगा, यहाँ पर ये -200 मिलीवोल्ट आएगा. तो जब ये -200 मिलीवोल्ट आएगा, और व्हेन Vi इज इक्वल टू सपोज 5 वोल्ट है, तो V नॉट क्या हो जाएगा? -10 वोल्ट. व्हेन Vi इज इक्वल टू 10 वोल्ट हुआ, तो V नॉट इक्वल टू कितना हो जाएगा? V नॉट इक्वल टू कितना होगा, जल्दी बताओ. यहाँ पे हम प्रैक्टिकल की बात कर रहे हैं, जहाँ पे +15 वोल्ट मैक्सिमम पावर सप्लाई अप्लाइड है और -15 वोल्ट मैक्सिमम पावर सप्लाई अप्लाइड है. तो इस केस में ये क्या होगा? -20 वोल्ट होगा क्या? V नॉट इक्वल टू -20 वोल्ट होना चाहिए क्या? बिल्कुल नहीं होगा. ये कितना होगा? -15 वोल्ट. इसलिए -15 वोल्ट होगा क्योंकि ये -20 हो नहीं सकता. -15 मिनिमम सप्लाई है, तो ये -20 पॉसिबल ही नहीं है. -15 पर ही आउटपुट रुक जाएगा. और इसके बाद मैं बढ़ाता जा रहा हूँ इनपुट. नेक्स्ट केस 6, व्हेन Vi is equal to 11 volt, then also V naught will be equal to -15 volt. अब क्या हुआ? इनपुट वोल्टेज बढ़ रहा है बट आउटपुट वोल्टेज बढ़ेगा नहीं. क्यों नहीं बढ़ पाएगा? क्योंकि यहाँ पर ये सैचुरेट हो चुका है और ये मैक्सिमम लिमिट क्रॉस करने लगा है. ठीक है, कोई प्रॉब्लम नहीं. मतलब ये है कि अब इसके आगे बढ़ाने का कोई मतलब नहीं है. ये -15 वोल्ट पे कांस्टेंट हो गया. अब मैं क्या करता हूँ? दूसरे साइड मूव करने की कोशिश करता हूँ. ये पॉजिटिव साइड जा रहे थे 0 से, अब हम चलते हैं नेगेटिव साइड. नेगेटिव साइड में व्हेन क्या होगा? Vi इक्वल टू -1 वोल्ट, देन V नॉट विल बी इक्वल टू 2 टाइम्स Vi, -2 टाइम्स Vi. दिस विल बी माइनस प्लस एंड 2 वोल्ट आउटपुट आएगा. केस 8, व्हेन Vi is equal to -5 volt, you will get V naught equal to -2 times Vi, that is 10 volt. So V naught will be 10 volt. Like this, voltage is changing, and I am going again. I am increasing values, and I will go in the next case up to case number 9. I will take Vi equal to -10 volt, then V naught will be equal to minus of -10 volt, and this is -20 volt. -20 volt आएगा क्या? बिल्कुल नहीं आएगा. आप बिल्कुल सही कह रहे हैं. ये रुक जाएगा -15 वोल्ट. नहीं, +20 की जगह +15 वोल्ट पे रुक जाएगा. बिल्कुल -20 नहीं आएगा, ये +20 आएगा, तो ये +15 पर रुक जाएगा. दिस इज +V सैचुरेशन. ये पॉजिटिव साइड में भी सैचुरेट हो रहा है. अगर मैं इससे और ज़्यादा इंक्रीज करता हूँ, व्हेन Vi is equal to minus 11 volt, then V naught is equal to minus of 2 times minus 11 volt, और दिस इज इक्वल टू 22 वोल्ट। आएगा क्या ये आउटपुट? बिल्कुल नहीं आएगा आउटपुट। कितना आएगा आउटपुट? 15 वोल्ट आएगा। मोर देन प्लस वी सेट इज नॉट पॉसिबल, is not possible in OpAmp, that we cannot go more than plus 15 volt. This is what is analysis of in a circuit which is having this inverting characteristics. If I try to draw a graph between input and output for this circuit, this graph is called transfer characteristics. In this graph, Vi will be in the input and V naught will be in the output. When input is 0, output is also 0. When I am increasing input, when input is 1 volt, output is minus 2 volt. So let me take some points here also. This is minus 1 volt, minus 2 volt, like this. So this is like this, minus 2 volt, लाइक दिस। ये चलता रहेगा लीनियरली, और ये जब -15 पे जैसे ही आता है वहाँ पे क्या हो जाएगा? ये कांस्टेंट। ये कब होगा कांस्टेंट? इनपुट के करस्पॉन्डिंग इनपुट कब कितना होगा? ये होगा 7.5 वोल्ट पे ये होगा -15, और -15 के बाद ये उससे कम होगा नहीं, इसके बाद ये कांस्टेंट लाइन चलेगी। ठीक है, तो ये 0 पे 0 है, और 0 से -15 तक जाता है। -15 के बाद फिर ये कांस्टेंट हो जाता है। नेगेटिव साइड जाएं, नेगेटिव में -1 अप्लाई करेंगे तो ये पॉजिटिव वैल्यू आती है, और नेगेटिव साइड में भी इसी तरीके का आएगा ये ग्राफ, क्योंकि ये पॉजिटिव वैल्यू देता है, और एक पर्टिकुलर पॉइंट के बाद ये सैचुरेट हो जाएगा। तो ये जो पर्टिकुलर पॉइंट है वो इनपुट का कितना होगा? -7.5 वोल्ट। कुछ भी हो सकता है, क्योंकि मैंने यहाँ पे कुछ वैल्यूज कंसीडर कर ली थी, इसलिए वैसा आ रहा है। कुछ अगर ये जनरल एक एम्पलीफायर है तो इस तरीके की कैरेक्टरिस्टिक्स आपको मिलेगी। इसको अगर मैं एक बहुत सिंपल से इसमें शो करूं तो आपको ऐसा एक लीनियर रीजन है, और ये एक सैचुरेशन रीजन है। यहाँ पे इस रीजन में क्या होता है? ये एज एन एम्पलीफायर वर्क करता है, linear amplifier. That means if you are applying the sinusoidal, then sinusoidal will come, but here it is not linear. So this characteristic is called transfer characteristic. Okay. Okay, so this way we can calculate the transfer characteristics, or we can draw the transfer characteristics. I had considered one circuit. ड्रॉ करने के लिए आपको चाहिए क्या था? इसमें रिलेशन बिटवीन आउटपुट एंड इनपुट। इस रिलेशन से, और इसके बाद आपको सैचुरेशन वाला पॉइंट पता होना चाहिए कि एक पर्टिकुलर पॉइंट के बाद सैचुरेट हो जाता है। तो दोनों अगर आपको पता है तो इसके बाद ट्रांसफर कैरेक्टरिस्टिक्स ड्रॉ कर सकते हैं। This is how transfer characteristics of operational amplifier is solved. This region is operating region. This is how transfer characteristics of OpAmp can be drawn. I will consider one more example. For this later on, but at present let us practice some more problems based on operational amplifier. Okay. Determine the output voltage if base currents are given as. So problem is determine output voltage if base currents of OpAmp are as shown in figure. This is a problem of practical OpAmp. Okay, thank you. So question here is like this. Here is 10k resistance in feedback, 100 nanoampere current in the inverting terminal base current, and 50 nanoampere base current is in the positive terminal. 1k resistance is in the input. Okay, so this is the circuit. Here one thing you can see that input is not applied. Both of the terminals are grounded. You can see this terminal is grounded and this terminal is also grounded. But what is given? These base currents. Ideally these base currents of OpAmp are 0. But as I told earlier also, मैंने आपको पहले भी बताया था कि अगर क्वेश्चन में दिया हुआ है, if these are given in the problem, then we will consider. So we have to consider them in this case. In this question we have to consider the solution method is same for all problems. We have first step 1 is apply virtual ground concept. And second step is to apply KCL at different nodes of OpAmp. So apply virtual ground, then this node is Vn, if this node is Vp. Okay, so by virtual ground, voltage at node N, negative node, is equal to voltage at positive node, and from the circuit we can see that the positive terminal is directly connected to ground, therefore the voltage of positive terminal will be equal to 0. So Vp is 0. As voltage of positive terminal is 0, therefore the voltage at negative terminal will be also 0. because Vp is equal to Vn from this. So from equation 1 we can say Vn is also 0. Second step to solve the OpAmp problem is apply KCL at node. So any other node available in the circuit, we have to apply KCL. So here I can say that the current the voltage the current coming into the circuit is from here, and the current going to towards output and this side into the OpAmp. So the current coming will be VA, you can say 0 minus Vn upon 1k. The current coming towards this will be the voltage here the 0 minus voltage here Vn divided by resistance is equal to आउटगोइंग करंट क्या क्या है. एक तो है 100 नैनो एम्पियर, दूसरी है Vn this voltage minus this voltage upon resistance. So Vn minus V0 upon 10k. Here we have seen that Vn is 0. So you have to now substitute Vn equal to 0 in this equation. So substitute Vn equal to 0, then tell me the answer. Just solve this equation and tell me the output voltage. Yes, great, very good. This is 1000 volt तो कभी हो नहीं सकता अंजलि. Soumya is correct. 1 millivolt. Ankush is also correct. Not correct. Ankush is not correct. And Vinay, this is correct. This is correct. Yes, yes. This will be 1 millivolt. Okay. Very nice. 1 millivolt is the output voltage you are able to calculate. So I will 10 to the power minus 6 is not correct. Okay, I would like to convert this into a equation. So in that case I am considering another circuit which have resistance R1 as input here and resistance R2 as input here. This is directly grounded and this is also grounded. Both are grounded, and resistance RF is in the feedback. Determine the output voltage if the current, base current is here IB1 and base current here is IB2. Let us see what is the equation of output voltage. Process will be same. This is the next problem. Next problem for our consideration. Here the IB1 and IB2 usually we take 0, but in this problem, as these are mentioned, therefore we have to consider them. Okay, so do the same process that we have done for the previous problem, that apply virtual ground, then apply Yogesh Kumar, what do you mean by plus plus? Okay, okay. Now solve the similar problem is here. Numerical values are not given, values are in the form of variables. Just I want to know that what is the output voltage in this circuit, means what is the dependency of output voltage in this case. I got answers. One answer from Soumya. This is IB2 into RF. The other option can be IB1 plus IB2 into RF. Yes, Anjali, she has written that this is minus IB2 into RF, so the other option, third option can be minus IB2 into RF. Yes, and last option I generally take none of these. So even if some other option is coming, then that will be none of these. But yes, I got this only some two options from all of you, that one option is plus IB2 into RF, other option is minus IB2 into RF. So we have to decide which one is correct. More are coming into the plus IB2 into RF. For that we have to see the last one also. In the last problem we got positive voltage. This was a positive voltage, therefore I can say that positive one will be the correct answer. So the answer for this problem is IB2 into RF. This one, option A is correct option. We can see that the output voltage is dependent only on the current flowing through this terminal, the bias current and the feedback voltage, feedback resistance. It is not dependent on these resistances. तो आप इनकी चाहे जितनी भी वैल्यू कम ज़्यादा कुछ भी कर सकते हैं. अगर इस केस में ये रेजिस्टेंस RF का वैल्यू इम्पोर्टेंट है. हमें ये जो वैल्यू है, मीन्स जो आउटपुट आ रहा है, ये आउटपुट आइडियली जीरो होना चाहिए. IB2 की वैल्यू बहुत स्मॉल होती है और ये आउटपुट वोल्टेज जीरो होना चाहिए. तो इससे ये पता चलता है कि जो रेजिस्टेंस है उस रेजिस्टेंस की वैल्यू कम होनी चाहिए, जितनी कम होगी उतना बेटर होगा। ठीक है, तो यहाँ पावर ऑफ हो गया है, इसलिए मैं ये कब कुछ पावर की व्यवस्था देख लेता हूँ थोड़ी सी। Okay, I think now it is visible. Visibility is okay. Okay. Okay, so now I will do little modification in this. What is needed, that output voltage should be 0. Actually, these currents are very problematic, because even without input, output is coming. So to make output voltage 0 or minimum, RF should be minimum, isn't it? RF should be minimum, then the output voltage will be minimum. Okay, so if these two current IB1 and IB2 are equal, then a new problem is that what will be the output voltage if IB1 is equal to IB2, which is both of the currents are equal, that is equal to IB, and R2 is equal to R2 equal to R1 RF upon R1 plus RF. For the same circuit, what will be the output voltage? This question, if IB1 equal to IB2 equal to IB, and R2 is R1 RF upon R1 plus R2. Process will be same. You have to take virtual ground concept and then go by KCL at node 1 and node 2. Okay, I can see the time is also over. So I am posting a Google form for attendance. I'm posting a Google form for the attendance. Just wait. Actually, we have lost this. Class. I lost the connection. So I am posting it. Just wait for the attendance. Okay, this will be available just for 5 minutes. I am posting it into this your chat box. Just don't leave leave it, because next class is cancelled, I know. So don't leave the chat. I have posted one. कॉलेज कब खुलेगा वो तो पता नहीं, ठीक है। एक मैंने गूगल फॉर्म पोस्ट किया है, इस फॉर्म में सबको अटेंडेंस फिल करना है। If anyone is not from the class, if joined in this YouTube live, please do not fill. Those who are from the EC biet jhansi, okay, I will give permission, no issue. Just wait. This was restricted. Okay, now you can fill. रोल नंबर, इसका चैट अटेंडेंस कई बार मिस हो जाता है। चैट में रोल नंबर मत लिखिए। मैंने जो गूगल फॉर्म पेस्ट किया है का लिंक दिया है, उस लिंक पे क्लिक करके आपको अटेंडेंस फिल करना है। यहाँ पे रोल नंबर मत लिखिए। Attendance will be considered from the Google form that is posted. You have to fill the Google form. सर गूगल फॉर्म में परमिशन मांग रहा है, अब नहीं मांगेगा। मैंने परमिशन अब मैंने उसमें ठीक कर दिया, और ऑलरेडी 20 रिस्पॉन्सेस आ गए हैं। 20 लोगों ने अटेंडेंस फिल कर दिया है। 24. डू नॉट शेयर विद योर फ्रेंड्स who have not joined. Those who are live, they should only fill. As soon as live streaming will stop, I will also stop the attendance. ओपन होगा क्यों नहीं? अब होगा। अगेन ट्राई कीजिए, ओपन होगा। राहुल जैन आएगा। You just close the previous one, because now I can see 45 people have filled the this attendance using the link. I will also make the Excel sheet visible to everyone so that you can see the attendance in your Google Classroom. I will post it into the Google Classroom so that you can see the attendance. Okay, thank you so much for joining. I'm stopping this attendance also. And live streaming also. No problem, Rahul Jain. You just put your roll number here. Okay. And do not fill attendance from two different email IDs. I have stopped taking more, so you do not fill from the many email IDs because the same link will be used again and again for taking attendance. Okay, thank you so much. Thank you, Tushar. And I think everyone have filled the attendance, and now I have stopped also. Thank you, Sakshi. Thank you so much. And you have to put answer of this question into the Google Classroom that question that I will post just now. That what is the answer for this problem? This one. Answer to this problem has to be posted into the Google Classroom for. I will decide marks, how many marks to be given for this. Okay. Thank you, Ananya. Thank you so much. Thank you, Sakshi.